Good morning, everybody. Today we are adding and subtracting fractions. So when we are adding and subtracting fractions, fractions and mixed numbers can be added and subtracted by these following steps. So number one, you have to find the least common multiple. 2, rename each fraction. 3, add or subtract the numerator and leave the denominator the same, and then simplify. Today, I'm not really going to be asking you to simplify as much, alright, because that's a whole nother lesson, so you don't really have to do step 4. But moving on down, I'm going to give you number 1 as an example, and I have a few videos that's going to be able to help you with number 1. So, step 1 was find the least common multiple, so I'm going to go over that one real quick using one of my videos. The least common multiple is basically also the least common denominator. So we're going to take a quick look at this video here. That should be telling us how to find that.
The new method is called finding the least common denominator because it involves using the smallest common denominator we can find instead of just using the product of the bottom numbers like we did in the first method. To find the smallest or least common denominator of two fractions, we need to figure out what the smallest or least common multiple of the two bottom numbers is. Now, in case you've forgotten, a multiple of a number is just the result of multiplying it by another whole number, like 1, 2, or 3. So here's what we're going to do to find the least common denominator, or LCD for short. First, we'll take the two different bottom numbers and start making multiples of each of them. We start with 1 times the numbers, and then 2 times, and then 3 times, and 4 times, and so on. It helps to arrange these multiples in a small table, almost like a scoreboard, so that you can keep things organized and easy to find. We'll stop making multiples as soon as we find an answer that's the same for both numbers. That answer is called the least common multiple, and it will become our new common denominator. Once we know what the least common denominator is, we have to figure out which whole fractions we'll need to multiply our unlike fractions by to get equivalent fractions with that common denominator. The solution is to use the same numbers that resulted in the common multiple. For example, if you multiplied by 4 to get the common multiple for the first unlike fraction, then you'll use 4 over 4 as your whole fraction. And if you multiplied by 3 to get the common multiple for the second unlike fraction, then you'll use 3 over 3 as your whole fraction for it. Have I lost you yet? Should make a lot more sense after you've seen a few examples. Let's start with this problem. 3 over 8. Ready for one more example? Let's find the LCD for these fractions. 2 over 9 and 7 over 12. Again, let's start by making a list of multiples for our two bottom numbers to look for a common multiple. 9 times 1 is 9, and 12 times 1 is 12, of course. 9 times 2 is 18, and 12 times 2 is 24. 9 times 3 is 27, and 12 times 3 is 36. 9 times 4 is 36. Aha! We found it. 36 is the least common multiple of 9 and 12. So we'll use that as our common denominator. Now let's figure out which whole fractions we need to use to make our fractions have that denominator. We use 4 over 4 for our first unlike fraction, since 4 times 9 was 36. And we use 3 over 3 for our second unlike fraction, because 3 times 12 was 36. There. Now when we multiply, we get two new but equivalent fractions that have a common denominator. Now we can add them with our simple procedure. On the top, 8 plus 21 equals 29, and we keep the same bottom number, 36. So that's how you use the least common denominator method. And it's really not that hard once you get the hang of it.
Alright, so there's your example for your least common multiple, which is really your least common denominator. So that is one strategy that you can use for number 1 here. And I'm going to give you another strategy that you can use for all 3 of these problems. So here's another strategy for these problems.
Hi, and welcome to Math Antics. In the last video, we learned how easy it is to add and subtract fractions that have the same bottom number. We call those like fractions. But often, you'll be asked to add or subtract fractions that have different bottom numbers, or unlike fractions. And we learned that the only way we can do that is to change our fractions so that they do have the same bottom number. Alright then, how do we do that? how can we change two unlike fractions into two like fractions? How do we get our fractions to have a common denominator? The answer is we need to use equivalent fractions. You remember what equivalent fractions are, right? They're fractions that have the same value but use different top and bottom numbers, like 1 over 2 and 2 over 4. They both represent 1/2, but with different numbers. Well, whenever we have two unlike fractions that we need to add, if we could find equivalent fractions to use instead, and if those new equivalent fractions had the same bottom numbers as each other, then we'd be all set. We'd have two like fractions, and we could add them using our procedure. Okay, but how do we find equivalent fractions that have a common denominator, or the same bottom number? Well, there's two main ways of doing it. In this video, we're only going to learn the first way of doing it, and I like to call this way finding the easiest common denominator. In the next video, we'll talk about another method that some of you may have already heard about. It's called finding the least common denominator. Okay, so how does this easiest common denominator method work? Well, even though this is an easy method, it might sound a little complicated at first. But don't worry, it'll make a lot more sense once you've seen a few examples. In this method, the common denominator is always going to be the product of the bottom numbers. In other words, it will be the number you'd get if you multiply the bottom numbers together. Basically, all we're going to do is take the two different bottom numbers and make two different whole fractions using them. Then, we're going to move the whole fractions to the opposite sides and multiply them by our unlike fractions. Doing this will give us two new equivalent fractions that will have the same bottom number. Then, we can add or subtract them easily. Okay, let's try a couple examples so we can see this method in action. Let's add the fractions 2 over 5 and 1 over 3. These are not like fractions because they have different bottom numbers, so we're going to change them. And the common denominator we will use is the product of the bottom numbers. 5 times 3 equals 15. We change them by multiplying each fraction by a whole fraction. The first whole fraction is going to be 3 over 3, because 3 is the second fraction's denominator. And the second whole fraction is going to be 5 over 5, because 5 is the first fraction's denominator. Next, we multiply starting with our first fraction. On the top, 3 times 2 equals 6. And on the bottom, 3 times 5 equals 15. So our first fraction has become 6 over 15. Now for the second fraction. On the top, 1 times 5 equals 5. And on the bottom, 3 times 5 equals 15. So our second fraction has become 5 over 15. Now we just add them using our procedure for adding like fractions. We add the top numbers, 6 plus 5 equals 11, and then we keep the same bottom number, which is 15. So that means the answer to 2 over 5 plus 1 over 3 is 11 over 15. That's pretty easy, huh? Alright, let's see one more example of this method. Let's add the fractions 7 over 8 and 3 over 10. Our common denominator for this problem is going to be 80, because that's what we get when we multiply the denominators together. 8 times 10 equals 80. We'll multiply our 7 over 8 by the whole fraction 10 over 10, and we'll multiply our 3 over 10 by the whole fraction 8 over 8. Then, when we do our multiplication, the 8 times 10 will give us 80 on the bottom of both fractions. For the top of the first fraction, we have 7 times 10 equals 70. And the top of the second fraction, we have 3 times 8 equals 24. Now that we have like fractions, we can just add the top numbers. 70 plus 24 equals 94. And keep the bottom number the same, 80. So, 7 over 8 plus 3 over 10 equals 94 over 80. Some of you see that this answer could be simplified. Be sure to check out our videos on mixed numbers and simplifying fractions to see how you could do that for your final answer. Alright, that's the first way you can find the common denominator and change your unlike fractions into like fractions so you can add or subtract them easily.
Alright, there's one more strategy for you. And then another strategy that you can use for all three of these is one that you should be familiar with, is the butterfly method. Big shout out to Ashley for demonstrating that for me earlier in the year, something that she had learned previously. So I'm going to show you a quick method for the butterfly method.
We can use this method for comparing, adding, and subtracting fractions. We start with our butterfly and our two fractions, 2/3 and 1/4. Then we multiply the diagonals. 4 times 2 gives us 8. And 3 times 1 gives us 3. Next, we need to multiply the denominators. 3 times 4 gives us 12. Here's what we have so far. We multiplied the diagonal 4 times 2 to get 8, the diagonal 3 times 1 to get 3, and the denominators 3 times 4 to get 12. And just like that, we have successfully completed the butterfly method, and now we're ready to compare, add, or subtract. Or hey, we could do all three. When comparing fractions, now that we have this common denominator, all we need to do is compare the numerators. So we can see that 8 is greater than 3, so that means 8 over 12 is greater than 3 over 12. When adding fractions, all we have to do is add the numerators and take the common denominator. 8 plus 3 is 11, and 11 over 12 is our answer. When subtracting fractions, all you have to do is subtract the numerators, 8 minus 3, and put them over the common denominator, 12. Since 8 minus 3 is 5, our answer is 5 over 12. Thank you for watching. I really appreciate it.
All right. So all three of those videos are methods for doing numbers 1 through 3. So down here it says blank blank can also be added or subtracted. And what we have here are mixed numbers. So the example I'm going to be looking at first is number 4. And again, I have another video to help you with this problem. These have like denominators, so that's a very good thing. It makes our job a lot easier. And then for my next example, I'll look at number 6. But first things first, number 5, when we're adding mixed numbers.
A mixed number to a mixed number, like 2 and 1/5 plus 4 and 2/5. Again, let's show our mixed numbers with the plus signs so we can see the real problem. 2 plus 1/5 plus 4 plus 2/5. Because all of these parts are being added and addition has the commutative property, it really doesn't matter what order we do the addition in. That means we can rearrange this problem to make it simpler. Now we have 2 plus 4 plus 1/5 plus 2/5. Adding the whole numbers is easy. 2 plus 4 equals 6. And adding these like fractions is easy too. 1/5 plus 2/5 equals 3/5. That leaves us with 6 plus 3/5, which is the mixed number 6 and 3/5. So when you add mixed numbers, you can just add the whole number parts to get the whole number of the answer. And you add the fraction parts to get the fraction part of the answer. That's why in a lot of math books, you'll see the addition of mixed numbers written in a stacked form like this. This is similar to the way you would stack multi-digit numbers up to add them. And it helps you remember that you can add the fraction parts and the whole number parts in 2 separate columns, and write your answer below the answer line just like in multi-digit addition.
Alright, that's going to be very useful for doing number 4. Alright. So a good example for number 6 is going to be the next part of this video.
Try one more example where we need to change unlike fractions into like fractions in order to add the mixed numbers. 3 and 2/3 plus 4 and 3/4. After rearranging the parts, we see that we need to add 3 and 4, which is 7. And we also need to add 2/3 and 3/4. Since these are unlike fractions, we need to change them. 3 and 4 are not multiples of each other, so it looks like using the easiest common denominator will be our best option here. 3 times 4 equals 12, so that will be our new denominator. To convert 2/3, we multiply it by 4 over 4, which gives us the new equivalent fraction, 8 over 12. And to convert 3/4, we need to multiply it by 3 over 3, which gives us the new equivalent fraction, 9 over 12. Now that we have like fractions, we can add them easily. 8 over 12 plus 9 over 12 equals 17 over 12. And that gives us 7 and 17/12 as our answer. But
Alright, that should give you a good idea on how to do number 6. So all of these 4 through 8 All of those videos should help you. And I'm going to post all these videos on Google Classroom. Alright, so on the second page of your packet it says, sometimes when subtracting mixed numbers, we must regroup. So brainstorm 3 combinations to make $1. So you can brainstorm any combination of coins that will make $1. Alright, so an example of this might be, I don't know, 3 quarters, which would give me 75 cents. And then 1 nickel, that's worth 5 more cents. And then I have 80 cents, so I'm going to need 2 dimes. Okay, there's one example on how to make $1, and you can ask anybody for some change and then count up your cents in order to make $1 and then write your examples here. So regrouping is like making change with fractions. So 1 is equal to how many eighths? So that would be 8/8. And then for fifths, it would be 5/5. So these are all ways to make fractions that are represented as 1. Or we could have 2 represented into thirds. So in that case, we're going to have 6 of those thirds. Okay? So basically what they're trying to explain here is that we have to break down our whole numbers into fractions. So if I had 1 and I had to convert that into a fraction of eighths, I would have 8/8. That would be 8/8. And the same thing here, it would be 5/5. Now here is a little bit different. You have 6/3. Well, the reason why 2 is broken down into 6/3 is that it goes over 3. Now 6 divided by 3 is 2. But you can also think of it like adding fractions. Alright, so what they want you to do in number 9 through 11 is break down your whole number into these parts. So if I needed to break down 1, I would break it down using the denominator. So 1 could really be 7/7. Take away 2/7. And that should make our problem a lot easier. So for number 10, I can break the whole number down into tenths. But I have 2 of those, just like here. I have 2 of those thirds. So in this one, I have 2 of those tenths. So when I break it down, I'm going to have 20 tenths. Now the reason for that is I have 2 whole numbers that are broken down into tenths. Alright, so if I have 2 whole numbers that are broken down into tenths, that would look like something like this. That means I have a total of 20 pieces. And I'll try to give you a quick example. So if I go ahead and here and take tenths, you can see that as I start to do this, I'm going to try to make one whole. And this is only going to be one part. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I could start putting these all together, right? And it's going to make a whole. And I could fit these pieces, but now you need to realize that when I'm doing this process, I'm going to have a total of 10 slices in this pie. But when I'm done, this is way harder than I thought, but that's okay. Alright, so I want to break down these holes into tenths, but the reason why I'm doing this is to show you that I have a total of 20 pieces. Alright, now I could continue that process all the way through. I don't want to take up too much of your time in this video, but this goes to show you that there is going to be 10 pieces in this pie right here, but that only represents one of the holes. So in the case where you have your video, your problem in the problem we're working on here, okay, for number 10, all right, what we want to see is how this and why this is 20 pieces. So I'm not going to do the rest for you, but just imagine if I had 10 pieces here, that means I need another 10 pieces. So I'm going to have a total of 20 pieces before I make a full circle. All right, you'd have a hole here and another one here, and I'd have a total of 10 pieces. So then after that, you get 17 tenths, which you could simplify. If you wanted to, which I'm not asking you to. I would take this improper fraction as an answer. But if you were to simplify this, you would see how many times 10 can go into 7, which can go in one time, with 7 left over. And your answer would be 1 7/10. So there's a couple examples from 9 and 10, and I want you to go ahead and do number 11. So moving on to the bottom, this is probably one of the most complicated processes. So now we can combine regrouping with mixed numbers. So when we are subtracting mixed numbers, one of the things that we might need to do is regroup if they need to borrow from their whole number. So for number 13 here, again, I'm going to show you another video and a couple examples that's going to help you do 12 and 14, and I'm going to use 13 as my example, okay? And I'm going to use another video to show you that.
For example, let's try the problem 5 1/7 minus 2 3/7, and let's use stack form. We're starting out with 5 1/7, so it goes on top, and 2 3/7 goes on the bottom. But when we try to subtract the fractions column, you'll see that we have a little problem. 1/7 is less than 3/7, so we can't subtract it without getting a negative number, which we'd really like to avoid. So what do we do now? Well, do you remember what you do in multi-digit subtraction when you have to subtract a bigger digit from a smaller one? Yep, you borrow or regroup from the column to the left. And we can do something really similar to that with mixed numbers. We can make the fraction part of a mixed number bigger by borrowing from the whole number part. In the video about adding mixed numbers, we learned that a mixed number with a...
And you're not going to need to see that part, so I'm going to skip ahead a little bit, because you can always refer back to that video.
In this example, we do that by changing the whole number part, 5, into 4 plus 1, and then changing 4 plus 1 into 4 plus 7/7.
So what he just did there is he broke 5 down, and he borrowed 1. But when he borrowed the 1, he changed that 1 into 7/7. So that's a lot like when we are doing our top over here, right? If we want to change 1 into eighths, it's going to be 8/8.
And finally, we we can combine that 7 over 7 with the 1 over 7 to get 8 over 7. Now the fraction on top is big enough to subtract 3 over 7 from. 8 over 7 minus 3 over 7 is 5 over 7. And then we just need to subtract the whole number parts. The top whole number used to be 5, but we borrowed from it, so now it's 4. 4 minus 2 equals 2, so our answer is 2 and 5/7. Let's try.
Alright. That video should help you out with number 13 right there. And for number 15, what I want to do for you is demonstrate that one for you. Alright, so I'm going to delete some of these that I so worked hard on to try to make a circle. A little bit difficult, takes a lot of time. Alright, so one thing I do notice that's different from numbers 12 through 14 is that in number 15, these have unlike denominators, so that's going to be a problem for us. So the first step that I want to take is to convert these fractions so they have the same denominator, and I'm going to use that method that we used, the easiest common denominator. So I'm going to make sure that I have my fractions, and I'm going to multiply each fraction by the other's denominator. So using that method of the easiest common denominator, I can see that my denominator here is 4, so I can multiply 4 over 4 to this fraction. And then on the same note, this is 8. This is my denominator is 8, so I can multiply by 8 over 8 for this fraction. So now I'm going to get two new fractions. So we got 4 times 4 is 4. We have 4 times 8, which is 32. On my next fraction, I have 3 times 8 for my numerators, so I'm going to get 24. And for my denominators, it's going to be the same as before. It's 32, so now we have equivalent fractions. Alright, so these are going to be my new fractions. So if I wanted to, I can plug those in here. So I'm going to use that stack method. I'm going to try to make this neat. So I have 7 and 4 30-seconds. And then I have 2 and 24 30-seconds. So now you can see that this number needs to be taken away from this number, but I'm going to need to borrow from that 7. So when I borrow from that 7, I want to break that 7 apart. Okay? So I can do that by changing the 7 to a 6 and breaking it down in a way that's 32 over 32. And I'm going to go ahead and clear this board here just because I think it's getting really messy. So I had 7 and 4 30-seconds and 2 and 24 30-seconds. So and just to show you how this process is going to work. So here I have 7 and 4 30-seconds. And here I had 2 and 24 30-seconds. So I want to break that 7 up by borrowing it. So if I want to borrow it, it's going to become a 6 plus the 32 over 32. That I can include into this fraction, so that I'm going to get a brand new fraction. So when I'm done, I'm going to end up with 6 over 36 that I can take away from 2 and 24, 30 seconds. Alright, so now my denominator always stays the same. I can subtract my numerators, so I can do 36 take away 24. I'm going to get a new numerator of 12. And then 6 take away 2 is 4. Alright, so here's going to be your answer for number 15. Now, if you wanted to simplify this, that is completely possible. You'd have to take the greatest common factor and divide it. So the greatest common factor between these two numbers is 4. So if I wanted to simplify 12 over 32, I could find its greatest common factor and divide the top and the bottom by it. To get a simpler fraction, something that's a little bit smaller. So I'm going to divide the top and the bottom by the greatest common factor. In this case, it is 4, which is going to equal 12 divided by 4 is 3. And then 32 divided by 4 is 8. So instead of 12, I'm going to have 3. And instead of 32, I'm going to have 8. There you go. So your answer could be 4 and 3/8, or it could be 4 and 12 30-seconds. All right. That is going to be it for today. Again, I'm going to post all of these videos on Google Classroom for today's lesson, and don't forget to do the quiz on quizzes today that I post. All right, guys, have a great day and stay safe.